Society must find a safer means of disposing the byproducts of large-scale chemical reaction. To start off, I will be talking about the different byproducts found in large-scale chemical reactions and how they can be disposed properly. But what is a byproduct? A byproduct is a product made during the manufacture of something else. Byproducts are usually known as harmful and useful byproducts. Examples of useful byproducts: glycerol from producing biodiesel, whey from the manufacturing of cheese, molasses from sugar refining. Some harmful byproducts include hydrogen sulfide, carbon dioxide, mercury, and uranium. Hydrogen sulfide. Natural gas processing plants produce harmful byproduct called hydrogen sulfide. This byproduct is highly corrosive and toxic. Hydrogen sulfide can occur naturally or can be produced through human activities. Hydrogen sulfide are naturally found in hot springs, crude oil, and natural gas. Human activities such as wastewater treatment, paper mills, petroleum drilling and refining help release hydrogen sulfide. But why is it dangerous? The effects of being exposed to hydrogen sulfide varies. At low exposure, hydrogen sulfide irritates the eyes, nose, and throat. At a higher exposure, hydrogen sulfide can result in unconsciousness or even near instant death. To prevent a harmful byproduct like the hydrogen sulfide from being exposed into the atmosphere, a process called the Claus process can make this harmful byproduct into a useful one. This process desulfurizes the content, which means it recovers sulfur from hydrogen sulfide. The most modified Claus system can remove up to 95% of its original content. The recovered sulfur is used to create products like medicine, cosmetics, fertilizers, and rubber products. Carbon dioxide. Power plants usually burn fossil fuels to create electricity. Fossil fuels include natural gas, coal, and the fractional distillation of crude oil such as petrol and diesel. When fossil fuels are burned, this creates a combustion reaction and one of the byproducts produced is carbon dioxide. This byproduct is then released into the atmosphere and is believed to be one of the contributors to the large amount of greenhouse gases.
So what's causing the modern warming? CO2, carbon dioxide. When we look at the history of the climate, what we find is that whenever CO2 has been high, it's been warm, and whenever CO2 has been low, it's been cold. And we can't explain the size of the temperature changes unless more CO2 makes it warmer. So what does CO2 have to do with temperature? It's simple physics, really. More CO2 makes it warmer through the greenhouse effect. The sun sends energy and heats the Earth sends back energy to space, and the CO2 gets in the way of some of that. That traps some of the heat here at the Earth and keeps us warmer than we would be. Without CO2 in the air, we'd send energy to space really easily. The surface of the Earth would be frozen, and we would be very unhappy, or we wouldn't be here. But as you turn up the CO2, adding more to the atmosphere, it traps more of that heat going up from the Earth, and so more CO2 makes it warmer. It's simple physics. CO2 is not the only greenhouse gas. Water vapor, methane, nitrous oxide, ozone, and others are also greenhouse gases. But CO2 looks like the main driver of the warming that's happening now. We know of no way to avoid the warming effect of CO2.
The increasing carbon dioxide levels also affects the ocean. Due to the large amount of carbon dioxide, the ocean serves as a place where the carbon dioxide sinks and reacts with the seawater to form carbonic acid. Since the Industrial Revolution, the oceans have become 30% more acidic. As the level of carbon dioxide increases in the atmosphere, so does the acidification level of the oceans in the world. A way to reduce the use of fossil fuels is to find an alternative energy resource like hydropower, geothermal energy, and solar energy. You can also help reduce it by unplugging any electrical resources that are not in use or just by simply switching lights off in rooms that are empty. A technology used to improve the efficiency of fuel power plants is to use what is called a carbon capture and storage. This process allows up to 90% of carbon dioxide emissions produced from fossil fuel power plants to be captured, preventing it from entering the atmosphere. The carbon captured is stored in a geological rock formation located several kilometers below the Earth's surface.